I need to share screen. All right. If you missed today, we're talking about something that we haven't talked about before, but I think should be very easy for everyone to understand. It is just simply ratios. And whoa, let's change that size. And ratios are just very similar to fractions with a very subtle difference. Let's say, for instance, that we have 30 people in the class, or 30 students, and 5 of them are left-handed. Let's just suppose. So 30 students total, 5 left-handed. Man, I'm running out of room. That means there's 25 who are right-handed. Please pardon my sniffles. What we would say is, well, if we want to say what fraction of the class is left-handed, we would say 5 over 30, right? Which simplifies to 1 over 6. That is what we call a fraction as a part of a whole. A ratio, on the other hand, could be a part-to-part ratio. So what we would say is the ratio of left-handed to right-handed students or people in this case. Well, for every 5 left-handed students, there are 25 right-handed students. So this here is not the total number of people in the class. It's just a ratio of this to that, of this thing to another thing. This would simplify to 1 to 5, right? Because we just divide each of these by 5, their common factor. So this would be different because we wouldn't say that the left-handed people are 1/5 of the classroom. You see how this draws an important distinction. It's a very important distinction because we're comparing a part-to-part ratio to a part-to-whole. Well, we could have a part-to-whole ratio, but in this case, a fraction is almost always a part of a whole. So we're going to examine that on the coordinate plane here. So what ratio does the point x divide ax and xb into AB? Okay, let's take a look at that. AX and XB. Let me zoom out a little bit. Okay, let me highlight these points. Man, this trackpad is annoying. So we have A right here, X right here, and B right here. So we're comparing the segments AX and XB. Okay, so AX, let's make that green. And XB, let's make that pink. If it'll go to pink. So what is the ratio of these segments? Meaning, what is the size of them, the length of them in comparison to each other? Well, thankfully, since these are vertical lines, vertical segments, we can easily just count these distances. So let's do that. Let's see. So AX, let me go back to blue here. AX is equal to, let's see, 1, 2, 3, 4, 5, 6. Let's say 6 units. This is a distance measurement, so it's not units squared or units cubed or anything like that. It's just the distance units. XB equals, let's count that. 1, 2, 3, 4, 5, 6. Okay, it's also 6 units. So what we'd say is AX to XB is equal to a 6-to-6 ratio. Well, we can simplify that. But we can just both divide those by 6, which is equal to a 1-to-1 ratio, meaning they are the same. They are the same amount, the same measurement. So the important distinction is that we wouldn't say that this is a 1/1 fraction, right? We would not say that. Each of these things makes up equal parts of this segment AB, right? This segment AB is 12 units. And for every 1 unit of AX, there is 1 unit of XB. I can't talk. So we might have to do this with more complicated measurements to find more complicated distances. Thankfully, what we have right now is either a completely 45-degree diagonal line, a vertical line, or a horizontal line. Let's take a look at the next one. What ratio does the point Y divide CY and YD on CD? Okay, so let's see. The point Y, okay, so this is Y right here. So we're using that to divide CY and YD. So let's color those. CY and YD. And let's count these measurements. So CY is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So CY equals 12 units. And YD is 1, 2, 3 units. So what we'd say is the ratio from CY to YD is equal to 12-3. Well, this simplifies as well. It simplifies from, oh, well, they have a common factor of 3. If we divide each of these by 3, we get 4-1. So I mean, just saying the length of CY is 4 times the length of YD. So that's the subtle difference. Again, we're not saying this is 1/4, right? If we're saying this is 1/4 of the distance or 1/4 of the whole, that wouldn't make sense because there's 1/4 and then the remaining is 3/4, which is incorrect, right? There's 1/4 and then there's 1 unit and then there's 4 more units, meaning there are 5 units in total. So we have to, it's really important to acknowledge that distinction. Last one. This guy here, it's a bit tricky because these units here are not quite 1 unit each, right? This would be 1 unit. This would be 1 unit if we went left or completely left or right or completely up or down. But what we do in this case, what we could do is effectively use a distance formula, Pythagorean theorem, if we wanted to. You know what? I know you guys don't like that, but we're going to do it. So we make what we call a distance triangle for these. Okay, what ratio does the point Z divide EZ and ZF? So that's this distance, EZ. and this distance ZF. So what we do is we're going to see the vertical and then horizontal change in location in units of each of these segments. And I just got an email. So let's do that. So we can think of this almost as a right triangle Pythagorean theorem. A squared, B squared, and C squared, and we're looking for C. Or I mean, we have A, B, and C, excuse me. And we use the formula A squared plus B squared is equal to C squared. Well, A is 1, 2, 3 units. This is also 1, 2, 3 units. So we'll say, well, EZ is equal to, well, C squared is equal to 3 squared plus 3 squared, right? C squared, then we would say is equal to 9 plus 9. So C squared is equal to 18. So we'll say C is equal to the square root of 18. So that means if we say this value C is the length of our segment EC, we'd say, okay, well, EZ is the square root of 18 units. Now let's compare that to ZF. Well, ZF goes down 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And it goes to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Some of you might be a bit ahead of me on this. So ZF, if we were to use the same formula, so we'll say C squared is equal to 9 squared plus 9 squared. So C squared is equal to 81 plus 81, meaning we simplify that to C squared is equal to what, 162? So C is equal to the square root of 162. Well, that's kind of tough. How do we compare these? The square root of 18 versus the square root of 162? Goodness. I'll tell you what we do. The funny thing is, I don't know how much we remember, because I wasn't here, the properties of square roots. What we're going to do is convert these. So let's do that over here. The square root of 18. So let me highlight these first. We have the square root of 18 and the square root of 162. Square root of 18 is equal to the square root of 9 times 2. This is equal to the square root of 9 times the square root of 2. This we can do only if we're multiplying. We can't split up what's under the square root if we're adding what's under it. So the square root of 9 is equal to 3. And then we say it's 3 times the square root of 2. So we converted that. Let's do the same thing. Let me go up here to make some more room with the square root of 162. Square root of 162. Well, what perfect square is, oh goodness.
Students, if you're taking the AP Spanish exam, please meet in the new Falcon foyer by the main office. If you're taking the AP Chinese exam, please meet by the auditorium. Thank you.
So we want to look for a perfect square that is a factor of 162. Well, we determined earlier, just by adding these 81s together to get it, that this thing is divisible by 81. So we'd say this thing is equal to the square root of 81 times 2. So that means we can simplify it to the square root of 81 times the square root of 2. So the square root of 81 is 9. So we'd say it's equal to 9 times the square root of 2. So we have a nice ratio now. Man, I'm running out of room where to put all this. I'm going to erase a little bit. So if you need this, you're going to have to rewind. So our ratio is 3 root 2 to 9 root 2. Sorry, 3 root 2 to 9 root 2. These we can easily simplify. They're both multiplied by the square root of 2. So we can say it's a ratio of 3 to 9. Does that make sense? Square root of 2 is just a number. It's multiplied to both of them. We're going to simplify that ratio. And 3 to 9, we can also simplify this as well. They're both multiplied by 3. So we'd say this is a ratio of 1 to 3. That was a doozy, but I hope it helped. See you all in class.